Hello guys, welcome back to our YouTube. So today I'm going to explain you all about the matrices and determinants weightage and roadmap to get into IIT by following my videos. So let's have a look at it. So here 2 to 3 questions in JEE mains and JEE advanced from matrices and determinants, and 3 to 5 questions in MSET examination. MSET examination is state level examination in Telangana state, and also these questions may be appear up to 3 to 5 questions in all the state level examinations of entrance examination of engineering. So let's have a understanding of the concept very clearly about the determinants and matrices now. So this is the introduction. So we will go into the deeply into the introduction and the concept of matrices and determinants now. So let's have a look at it here. This is the determinants and matrices. Introduction to determinants. The determinant consists of 2 rows and 2 columns is D. D is equal to A1, B1. This is the determinant. So here 4 elements are present in this determinant. So its value is given by D equal to A1, B1. So here it is said to be as like this: A1 into B2 minus A2 into B1. So here this is the determinant. Determinant can be represented as like this. So it's the value of determinant. A determinant which consists of 3 rows and 3 columns is called a third order determinant, and is of the following form. So if mainly for JEE mains and JEE advanced problems, there is only up to 3 cross 3 is given. Up to row and columns of 3 is given. That is that row by column equal to 3 by 3 or 3 by 2. It is given up to that only because you are in lower standards, uh, up to 12th. So in the engineering you can be given us like 4 into 5 by 4 by 5 matrix. In the engineering gate examination you will be given like that, but for JEE, no, JEE mains and JEE advanced you will be given up to 3 into 3 by 3 matrix. So its value plus this will be here, first will be plus. So here it will be plus, it will be minus, it will be plus. A11 into A22, A33 minus A32, this one. First A11 into A22 minus A32. First this row, this column and this row will be erased, and remaining will be multiplied cross sectional. So A22 into A33 plus A32 minus A23. So after that you will get the answers like this: determinant value equal to, by here also this one will be erased, and this will be multiplied, this will be multiplied, and lastly we'll get the answer as this one. This is the determinant of the given matrix. So here next, minus and cofactors. Minus and cofactors, let delta equal to, delta represents the determinant of the matrix. So here delta equal to what here? So I have explained you, it is up from the above. So here this will be sent to this here. So aij equal to element in first row, ith row, and jth column of delta, minor of aij. Aij means aij. I can be equal to j, or I cannot be equal to j. This is the definition of aij. A can be, I can be of belonging to natural numbers. So I can belong to natural numbers and j can also be belonging to natural numbers. So it is defined as a value of determinant obtained by the eliminating the first row and the jth column of determinant. So we need to denote the minor of aij by mij. So here minor is represented by capital M. So in the DLE also it is there. In the gate examination also it is there, but you can understand this. It is only for, this video is only for IIT and JEE mains. So let's understand this in the point of view of JEE mains and JEE advanced and MSET. So cofactor of denoted by Cij. Cofactor is denoted by Cij and minor is denoted by Mij. So here minus is what here? So you should eliminate this row and this column and this row, and remaining will be cofactor, and its value will be cofactor. The value will be minor. Eliminate first row and first column and first row. You will getting the determinant, and its determinant is the minor of the given Aij. Aij is the element of the one element of the mat determinant. So next, cofactor of Aij. Cofactor of Aij is minus 1 power I plus j. I plus j minor of Aij. So here cofactor is what here? Cofactor is uh, minus 1 whole power 1 plus j. So here cofactor was denoted for determinant process, so it is a minus here, so it is minus plus minus. For determinant we got cofactor as like this. So here for cofactor of Aij, uh, Cij is cofactor equal to minus 1 whole power 1 plus I plus j. So here find cofactor of A12 is your homework. Comment down in the comment section if you got the answer. So next, here Aij equal to, I am doing it here. So see, Aij A12 equal to Aij, I equal to 1, j equal to 2 here. So minus 1 whole power 3. 2 plus 1 equal to 3. So I wrote here 2. 3. Minor of Aij. Minor of Aij is what here? So minor of Aij is A12. A12's minor is what here? A21, A33, A21, A33, A31, A23. So here minus 1, A21, A31, A33. So negative will be multiplied to both the signs. A23 equal to A31, A23 minus A21, A33. So this is the cofactor of A12. So here you got two examples. You can easily understand what is the cofactor of Aij. So this is the explanation of cofactor. Next we're gonna see next evaluation of determinant. So here evaluation. So here value of any determinant can be obtained by adding product of all elements of a row or column to their corresponding factors. So here, so delta equal to what here? So delta can be equated as A11 into C11. So this one into this one, and here plus minus plus na. So here cofactor is what here? Cofactor is minus 1 into this cofactor minor minus 1 whole power 1 plus 1 is 2. So this is this, and you will get the answer as this only, plus minus plus. This is a short form for finding out the determinant. uh, the long method is this one, the short method is this one. So you can use this short method for finding out the minors and determinant of the matrix in the JEE Mains and JEE Advanced examination. So properties of determinant. So here the value of determinant remains unaltered if the rows and columns are interchanged. So here if d equal to what here? If rows and columns are interchanged, the determinant won't be changed here. So determinant will be same, equal only if the rows and columns are interchanged also. If I am taking this as A1, A, this is A transpose. Determinant of A is what? Determinant of A is equal to determinant of A transpose equal to D. This is the property 1. This can be used in many problems. You can use this in many problems. I am going to explain the problems in next video. I am only explaining concept in this video. So here, if any two rows or columns of a determinant be interchanged, the value of the determinant changes in sign only. So here, see, if any two rows or columns of a determinant can be interchanged, the value of determinant changes in sign only. So here only two rows are changed here. What are the rows there? A2, A1, B3, row 1 and row 2 have been changed. The determinant. So it will be the sign of the determinant will be changed. Everything will be left unaltered. So this is the second property of the determinant. So next, if a determinant has all the elements 0 in a row or column, then its value will be 0. So if this will be 0, 0 into anything is will be again 0. So this, if any of the row or column, uh, it will be a 0 row or 0 column, then it will be said to be as the determinant equal to 0. We couldn't after long method of evaluation also, you will get the same answer. But in short method you can directly write it as 0. I am explain you how it get to equal to as 0. Next, we'll understand next property of determinants. So if a determinant has any two rows or columns identical or proportional, then its value is equal to 0. See here, without a k, it will be totally equal. So here, if the determinant in the determinant any two rows are equal or proportional, here k is a proportionality constant. Like this, it will be a1 proportional to a1. So a1 equal to k a1. So r1 equal to k r2. So here r1 equal to k r2. K can be for a1 equal to k a1, k equal to what here? K equal to 1. For r1 equal to kr2, kr2, the answer may be different. So here, so here r1 equal to kr2. So here it is proportional. R1 directly proportional to R2. This is the proportionality constant here. K is a proportionality constant. So next, if all the elements of row or column are multiplied by the same number, then the determinant is multiplied by the number. So here, if for any value, for any row or column, if a k or a constant is multiplied, so it can be multiplied outside directly. So here, then d complement equal to what here? D complement equal to kd. K is can be directly sent outside, and we can directly simplify it in the simplification format. We can directly calculate the determinant value. So here k, if k is sent to, k is a big number like 446, like that. If 446 is a big number, 446 into 1, 446 into 2, 446 into 3. So here 1 2 3 can be inside and 446 will be outside. So you can directly calculate the value of the determinant and directly write the answer as something. You get the answer, you can write it and multiply it with the k 446. So it's an example I have explained in this video. Next, if each element of any row or column can be expressed as sum of two terms, then the determinant can be expressed as sum of two determinants. That is that a1 plus x, b1 plus y, c1 plus z. So here uh, you can, if a1 plus x, this is uh, you can easily multiply it. You can easily add it. So here we should take only one row. Only one row must be added, not two, not the three rows. You must think that there is a common mistake or common confusion in the students that you can add easily two determinants, but that is wrong. It is for the property of multilinearity property. I'll explain in the next video. As a separate video, I will explain multilinearity property. It's very much important to solve the problems. You don't confuse for this problem. It's correct only, and this you must add only first row or any other row, any one row you must add, so that the determinant remains constant and equal. So next, the value of determinant is not altered by adding the elements of any row or column a constant multiple of the corresponding element of any other row. So here see, by adding two elements of any row. So here it is not altered. So here see, the value of determinant. Value of determinant means what here? This determinant does not altered. It's not altered. Adding two elements of any row. Adding two elements of any row means what here? This element is added to this. So this element is added to this. This element is added to this. This element is added to this. So here a constant multiple of the corresponding elements. So here corresponding elements with what here? Corresponding means next element. R1 means R2. R3 means R2. That like that. Change R3 as sum of R3 and NR2. So here corresponding means which is near to that. Near to that means it is nearer to the that number. So here we will take R2. R2 is taken as always because it's near to both of them. 1 and 2 also. 2 is nearer to both of them, so you can take any of that. Any of the R3 or R1. So for that, this is the operation. Operation of a determinant is not altered by adding to the elements of any row or column a constant multiple of the corresponding elements of any other row or column. So this is the example here. D dash is equal to D. It is not altered by doing this operation. This is all about the operations of determinants. It's very important. Determinants operations are very important in solving all the problems in JEE, JMETS, JEE Advanced, and also CBSE and MSET, and also Telangana State Board of Intermediate Education, TSB, BIE. So this is next. We should understand the Cramer's rule. Cramer's rule is very important, but it's not included in the CBSE syllabus. So let's take two variables a1x plus b1y equal to c1. Is the linear variable, linear polynomial in two variables. So here a1x plus b1y equal to c1. C1 is constant here. So here, so this to solve this problem by using this matrix form, we can use this Cramer's rule. So here x equal to what here? Dx by dy, dx by d, y equal to dy by d. So for finding dx and dy, we should find easily. We can find easily. D is what here? D equal to, so here D equal to what here? A1 A2, B1 B2. So this is D. So dx is what here? C1 C2, B1 B2. So for x we should take remaining of this remaining of b remaining values of constant coefficients of b1 and b2 and c1 and c2 for this here. dy equal to what here? A1 A2 C1 C2, A1 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 A2 C1 C2. This you should take for finding out the values of this value, this x values. So here you will get answer as similarly n equations in n variables can be solved. So in this way you can solve n equations in ways. So here consistency and non-consistency of the equations we will see afterwards. For that we will solve this example. Three variables a1x plus b1y plus c1z equal to d1. This is first equation. This is second equation. This is third equation. These are linear variables in linear polynomial in three variables. X, y, z are variables in this polynomial. So d1, d2 or d3 are constants here. So here find out x equal to what here? X equal to dx by d. So here we can say that dx equal to what here? D equal to this one. So this can be represented in the form of this way. Okay, it can be represented in this way. By short form is given here. the textbook. It is a short form, but it can be represented in this way: a1, b1, c1, a2, b2, c2, a3, b3, c3 equal to into xyz equal to d1, d2, d3. So here d equal to what here? Dx equal to, let's take dx equal to y. So this is y, ds is x, this is d. D equal to this one, d equal to this one here, dx equal to this one, dy equal to this one, dz equal to this one. So consistency, we will see this consistency by looking at it here. Consistency of system of equations. So here consistency means what here? Consistency means how consistent are they. So let's understand this sentences one by one. If d not equal to 0, then the given system of equations are consistent and having unique solution. So if d not equal to 0, if d equal to 0, what happens? D equal to 0, then all these values will be uh, so all these values will be 0. There does not exist any value of the xy z values will be 0. Xy values can be infinitely inconsistent and have no solution here. So if then d not equal to 0 only, the equation has unique solution here. If d equal to 0, at least one of dx, dy, dz is not 0, then the equations are inconsistent. Inconsistent means what here? Inconsistent means it's a property of the matrix. Property of the matrix that defines having no solution here. No solution means inconsistent. So next, if d equal to dx equal to dy equal to dz equal to 0, the given system of equations are consistent and have infinite solution. So just now I had told you, I will explain this by showing you in the paper. So here, if a0 0, if a1 d a1 equal to 0, this total value will be 0, then it will be having infinite number of solutions. It can be anything up to infinity. The answers will be 0 only. So here, consistency means what here? So consistency means this must be this, its value must be equal to this value. So here, for any other d1, d2 and d3 values, this multiplication must be not equal to this. So it is said to be as consistent when d equal to 0 here. So next, for first one, d not equal to 0. For d not equal to 0, what here? D not equal to 0. Here x value can be anything. X value can be find it out easily. For correct d values given d1, d2, d3 are given, x value can be anything. A1, A2, A3, or like this also we can write b1, b2, b3, c1, c2, c3. So we can write it like this also. So here, for any, if these values are given here, x values we can find it easily, and there is consistency. For this 2 multiplication we will get the answer as this one. So it is said to be as consistent. These two are multiplied, a into b, we will get a c. This is consistent. But here it is not like that. For any value of this, it can't be equal to this, because here it will be 0, it not equal to something, 1 2 3 and so on. It is not equal to that. So here it is not consistent. So next, for next case, for d equal to dx equal to dy equal to dz equal to 0, then the given system of equations are consistent and have infinite solution except the case of parallel planes where there is no solution. So here, if all are equal means what here? So if all are 0, this one, and also this one. For any value of xyz, this will be 0. So for any value of xyz, this into this will be 0 here. So it is said to be as consistent, but only for parallel lines have infinite solutions. Here anything x can be infinity up to minus infinity to plus infinity. You can take anything. The answer will be 0. So here x y z values can be infinity. So exception is what here? Exception is, so here it can be repeated in the gate examination also, and also in the engineering point of view. It is also important in the first semester examinations of SCE. SCE means semester and examinations. It is also important for JEE mains and JEE advanced also. So this is all about consistency and homogeneous of equations. So here at the parallel planes where there is no solution, when planes are parallel like this, parallel to each other, there is no solution. Solution is no here. There is no intersection. Since there is no intersection, there is no solution for that, for those planes. So this is uh, about a consistency of equations. So next we're going to discuss about homogeneous system of equations. D1 equal to D2 equal to D3 equal to 0. So here the system of equations is called as homogeneous equations. So here if we take this like this, a1 b1 c1 a2 b2 c2 a3 b3 c3 into x y z equal to 0 0 0. This is said to be as homogeneous equation because it is in the form of ax equal to 0 here. Ax equal to 0, so it is said to be as homogeneous equation. So non-homogeneous equation we will discuss now. So here solution of homogeneous equations is always consistent. So as x equal to 0, y equal to 0 and z equal to 0 is always a solution. So here xyz is always a solution. This is known as trivial solution here. If x comma y comma z are is equal to 0, then for any value of a1 b1 c1, for any value of a1 b1 c1, a2 b2 c2, a3 b3 c3, 0 0 0 0 0 0, so it is said to be a trivial solution because for any value of this multiplied with 0, you will get this only, 0 only. So we will get to know as it is as follows as 0. So here it is said to be as trivial solution. Next, for homogeneous equation, if d not equal to 0, then x is equal to 0 equal to y equal to z. So here for homogeneous equation d not equal to 0, d not equal to 0 is what here? A1, this a1 b1 c1 not equal to 0, then the thing is what here? The thing is x comma y comma z equal to 0 here is the only solution for that. So this is about homogeneous equation. Next, for homogeneous equation, if d equal to 0, then there exist non-zero solutions, non-trivial solutions also. D equal to 0, if d equal to 0, what happens? If d equal to 0 here, 0 0 0 0 0 0 0 0 0, x values can be varied. X values can be varied for different for multiplication of any value of x, you can get 0 only for homogeneous solutions, homogeneous equations. So non-trivial solutions also you will get. This is all about homogeneous equations and also consistency of system of equations. So next, applications of determinants. Following examples of shorthand writing of large expressions. Area of triangle whose vertices are x r, x r comma r. Applications means where you can use this uh, determinants. This is the application of determinants. So let's understand this. It's very important because in real life you can use these formulas to easily calculate any value or anything in the form of matrices and determinants. So here d equal to 1 by 2 x1 y1 1, x2 y2 1, x3 y3 1. So here this is equal to d equal to 0. Then the 3 points are collinear. Collinear means what here? Collinear means they are on the same line. They are on the same line. So here if this determinant equal to 0, then they are said to be as collinear. The collinearity can be easily determined by using this determinant. This is the application of determinant. So here equation of straight line passing through x1 comma y1 and x2 comma y2 is, so equation of straight line. Straight line equation is what? X y 1, x1 y1 1, x2 y2 1. 1 is equal taken in all the cases because 1 is as a and is an unitary constant. So it is taken as in the three cases. Next, the lines a1 x b1 plus these are the lines are concurrent if a1 b1 c1 a2 b2 c2, this determinant equal to 0 here. Concurrency case I will explain in next video. The video length will be increased, so I am not explaining in this video. I'll explain separately. For every question there is an answer in my videos in my channel, so please watch and enjoy my channel by watching my videos. Enjoy learning by watching my videos. Next, represents a pair of straight lines if. This represents a pair of straight lines if. This is the condition here. ABC plus 2FG, 2FGH. This is a pair of straight line. It can be a curve equation, but if it is said to be as pair of straight line equation, this must satisfy this. This must satisfy this. So this is a short method of representing this. This is a short method of representing this formula. So here AHG, HBG, HBF, GFC determinant equal to 0. Then it will be said to be as it is said to be as pair of straight lines. Next, to find variable x comma y comma z etc in linear equations, we can use determinants. So to find the values of x comma y comma z, in the real life we may come to know that there are so many problems for solving this x comma y comma z values in the calculation of how many shades we can get for this amount of customers coming to the uh, our showroom, etc. For these all things we can use Cramer's rule and determinants applications. Determinant we can use that and solve for the solution. Some more properties of determinants. Determinants of a skew symmetric matrix of odd order is 0. So odd order means what here? Skew symmetric. Skew symmetric means what here? Minus a plus, minus a plus, minus a plus. So here 0 0 0. It will be 0. So here next, Pfaffian means Pfaffian matrix is not in your syllabus. So it is for what is the value of Pfaffian matrix means of order, even order. We can use Pfaffian matrix, but it's not in your syllabus, so it can't be explained here. So determinant, it is Pfaffian matrix is always also there in my YouTube videos, so please check out in my YouTube section. Determinant of a skew symmetric matrix of even order is always a perfect square. So here it is always a perfect square. So in the options you can easily check which is a perfect square and tick out that problem. Tick out that problem or option. Delta n power n minus 1, where n is the order of determinant, is equal to the determinant made from the cofactors of elements of determinant. So here n minus 1. So here n is what here, row into column. Always these properties are represented only for square matrix, not any rectangular matrix or something. It is only for square matrix properties here. You will get to know that there are only square matrix problems in the IIT and JEE Mains, so it's easy for you to get the solutions easily and options correctly by using these equations. So here, where AIs are cofactors of AIs, determinant of a diagonal matrix is a product of its diagonal elements. So here D equal to 500 020 006. So here diagonal matrix is a product of its diagonal elements. So here if a diagonal matrix, for diagonal matrix its product of its diagonal elements are equal to the determinant. So here it's a property of the determinant of this diagonal matrix. So here if a determinant considered as a polynomial becomes 0 when x equal to a, then x minus a is a factor of this. This is an application of factor theorem. So here this is the application of factor theorem. I will explain factor theorem in the next video. But now for that, if a determinant considered as a polynomial becomes 0, if this determinant will become 0, x equal to a, then x minus a is a factor of this. So x minus a is a factor of this. This is an application of factor theorem. Because d equal to 0, when x equal to a, x minus is factor of d. So here x minus a is factor of d here. So here this is the fifth property. I will explain this clearly in next video. This is very important property for understanding determinants. Determinants applications. The sum of the product of the elements of ith row or column with the cofactor of the corresponding elements of kth row or column is 0 provided I not equal to k. So this is the sum of the product of elements of ith row or column with the cofactor of the corresponding elements of the kth row column is 0 provided I not equal to k. This we will understand in the next video. So see here, it can be easily understood in this method. So here summation j equal to 1 to n aij equal in aij of into ckj equal to 0 if I not equal to k here. So this is the first property. I'll explain this in the next video. It's complex to understand, so you will understand in this video the basic concepts, so that you will get a grip on the subject. So next, a equal to 1 to n aij cik equal to 0. So here summation of aij cik, here aij means what here, matrix element from 1 to n. Its summation will be equal to cik. Ik is what here, k is a constant here. So here see and understand again. Kth row, the sum of the product of the element of the ith row or column with the cofactor of the corresponding element of kth row is 0 provided I not equal to k. So its summation will be equal to 0. If I not equal to k and j not equal to k, then it will be satisfied. I, here j. So it is the common property of determinant. It is very important. Keep star mark on it. It's very important for your JEE and JEE Advanced and JEE Mains also. MSET point of view also. Det of AB equal to det of A into B. So here determinant of both product of both the matrix is always equal to determinant of singular multiplication of determinant of single matrices, single determinants. So here it is shown here and proved here. Determinant of a triangular matrix is a product of its diagonal elements only. Triangular matrix is what here? This is triangular matrix. So here its its determinant is equal to always equal to its its diagonal elements product. So here it is this. This is here it is this. So special determinants. Special determinant is circular determinants. The elements of the rows or columns are in cyclic arrangement. So A B C B C A C A B. So here it will be minus A cube plus B cube plus C cube minus 3ABC. Circular means what here? Cyclic arrangement A B C B C D B C A C A B like this. A B C after B C A after C A B like this. If that is true, for that you will get the answer as A cube plus B cube minus C cube minus A B 3ABC whole of minus. So next it is a common property 1 in 1 A B C A square B square C square A minus B into C B minus C into C minus A. So if this is there, you can directly write it as in this way in the determinant form. So here next we should find this value. If A cube B cube C cube is there, now in the place of A square B square C square, if it is there A plus A cube B cube C cube, A minus B into B minus C into C minus A into A plus B plus C. So it will be there like that. So it is same here also, it is same. Is the difference is square here, square of the second row, and the cube is same as third case. So here AB plus BC plus CA, it will be coming here. So here next multiplication of two determinants. Determinant of A1 B1, if it will be there, so here you can directly write it as this is multiplication of individual elements. So here you can write it as like this, individual elements. It is here only I told you this only is represented here in a separate column. So next summation of determinants. Summation of determinants is what here? So summation of determinants delta r equal to f of r g of r h of r. So here a b c l m n, where a comma b comma c l comma m comma n are constant independent of r. So here summation of delta r equal to 1 to n equal to summation of f of r equal to 1 to n a l. Here functions of r can be elements of only one row or one column. None of these elements other than row or column should be independent on r. So this is very important. So you can write here, if you get into summation, here also you will get into summation here from r equal to 1 to n, here from which here summation is under which limits, here also these functions are under that limits. So here the summation of determinants has been successfully explained here. So if you have any doubts, please let me know. Don't hesitate to contact me. I will give my email id so you can contact there to me. So here next determinant and integration of a determinant. So here differentiation and integration of determinant. So here determinant integration and differentiation. So let's understand this. F1 of x, F2 of x, F3 of x, G1, these all are there here. So here you can write it as delta delta dash x. Delta dash x equal to what here? So first you should determine this first row, next plus a second row plus a third row. This will be the total determinant of this. So you can't do the total determinant if the f of f1 of x, f2 of x, f3 of x, these are all complex. that means these elements are in the values of x cube minus y cube minus z cube, like that. It's in the complex way. You can do individual derivative and then add them individual derivative of row 1, next row 2, next row 3, and add summing of them will give the answer. Next, integration of determinant will be uh, calculated from a to b. Then it will be given only to the functions which are there in the inside. So constant won't be taken, only the functions will be taken for the integration, not the constant. Here lambda 1 lambda 2 are the constants here. That is explained here now. The formula is only applicable if there is a variable only in one row or column, otherwise expand the determinant and then integrate. So here this formula is only applicable if there is a variable only in one row or column. So it is only applicable for only one row or column. There is a variable that is applicable, uh, rather that you must integrate by expanding the determinant. So here is the next step. We should find a up to here. Let's stop it. So introduction to matrices will be continued in the next video. Till then, please subscribe to my channel, hit the like button, hit the bell icon, and activate the notification bar. Thanks for watching, friends. Bye.